Hi guys, earlier I gave you a hint for number 10, so I'm gonna reorganize the hints and then actually give you a little more hints for this problem number 10. So first of all, this problem number 10 says we want to prove the altitude of a triangle. So we have a triangle, there's an altitude here, are isogonal conjugates of the circumradii to the vertices of the triangle. We just need to prove one, so therefore I'm going to draw one altitude. This will apply to all the altitudes, right? So I'm going to draw one altitude, and this is, it says circumradii, that means we need to find the circumcenter, and here this is AO is the one of the circumradii. O is the circumcenter. Now we want to prove that these two segments here, they are isogonal conjugates of each other. That's what we want to prove. And in the last video, I kind of explained what's given, what to be proved, and also along with that, hints how to proceed, right? So because it involves the isogonal conjugates, so we want to draw the angle bisector. So I'm going to call AE as the angle bisector of ABC. So in other words, if I were to prove this, I'll first draw the AE, which is the angle bisector of the angle BAC. And eventually, to prove that these two are isogonal conjugates, we want to show that these two angles are equal. And now the hint comes, here's the hint. Call this the intersection of this angle bisector and BC as point E. Extend this AE to meet the circle at the circumcircle at say F. Now my suggestion was to show that these 3 points O, A prime is the median, by the way, at the midpoint of this triangle ABC for the side BC. You want to show O, A prime, F being collinear, okay, being collinear. Now, what does that mean? That means this, because this is perpendicular bisector, this circumcenter, this is the midpoint, so this is the perpendicular bisector. How do you show that these 3 points are collinear? I'm going to give you a hint real soon. But now, what's the benefits of showing that these 3 points are collinear? Because once you show these 3 points are collinear, and then you know this is the perpendicular bisector. That means these 3 points on a straight line, and this line should be perpendicular to BC. And then you do know that this will be 90 degrees. And this altitude certainly forms a 90-degree angle to the segment BC. Therefore, these two lines are parallel, right? They're parallel. And then once you know they're parallel, you do know these angles, these two angles are equal. So I say this is my angle 2, this is angle 3. Then you know these two angles are equal. And also you do know that this is the this triangle, in this triangle, AOF. AO and OF would be the circumradii. Again, we already proved that OA prime F is collinear, so therefore this should be on a straight line, and therefore it's a radius, right? So because these two are radius, and therefore this triangle AOF should be a isosceles triangle. Therefore, angle 1 and angle 2 should be the same. Now, that means you've proved that angle 1 and angle 3 are the same. Therefore, AD is isogonal conjugates of AO. Now, back to the, how do we prove that OA prime and F are collinear? You know, OA prime is perpendicular bisector. If you can show that F is also on the perpendicular bisector, that means these 3 points have to be collinear. And how do you show that F is on the perpendicular bisector? That's the first thing that I introduced back in section 4.1. How can you tell a point is on the perpendicular bisector? you just need to show that f is equal distance to both endpoints, right? So in other words, you want to show f is equal distance to the point B and point C. You have to take advantage of the fact that AEF is angle bisector. So here's the hint. How do you show that F is equal distance to B and C? So prerequisite is this. I'm gonna remind you that in Appendix 5, number 22, it says, so here's what it says. If you have angles, like these two angles, they are corresponding to the same intercepted arc, which is this one, then you know these two angles must be the same. So in other words, if you know two angles are the same, then their corresponding intercepted arc should be equal. So in other words, if I tell you that, hey, this angle is the same as this angle, then you can tell for sure this intercepted arc for this angle should be equal to the intercepted arc to this angle. So now let's take a look at how we actually use this fact to show that f is equal distance to B and C. First of all, you already know that this is angle bisector, right? Therefore, these two angles have to be equal. So this is a different color here. So this pink angle and then this pink angle, they're equal. And because of that, you know that this arc should be equal to this arc. Why? Because the angles are equal. So therefore, this arc should be equal to this arc. And therefore, F to B should be F the same distance from F to C. So therefore, we finished proving the equal distance, this fact. So now it's your turn to put everything together in a very nice writing. Make sure that your flow is good. One comes after the other. Every statement should be supported.